This video consists of your week 2 practice, and as usual, I will present a problem to you for to try, and you are to do it. And then once you submit your answer, the video will resume where I show you how to perform it. So here is your first question. When you're asked to simplify any polynomial, you're basically trying to get it down to as few terms as possible, combine any terms that could be combined, that sort of thing. For basic multiplications like this, you just need to make sure you group these and multiply them together correctly. So if I have 11x squared times 4x cubed, I can multiply the coefficients together, and I can multiply the powers of x together. And so, I show the regrouping on this, but even as I go along with this, you're going to see that I don't always regroup them. I mean, you sometimes regroup these in your head and be able to keep track of them without having to add, additional steps in writing to the process. So, but here I am going to do 11 times 4 and get 44. The x squared times x cubed, I had to remember the exponent rule. When I multiply powers of the same base, I would add the exponents. So I'm going to add the 2 and the 3. I end up with 44x to the 5th. And that's the basic premise behind it, no matter how many variables you have, no matter how many powers you have. So let's look at a slightly more challenging example. So for this one here, not only do you have x's and coefficients, you have y terms. You also have these parentheses where the entire quantity is being raised to a power as well. So you basically have to try to follow your order of operations. Now, inside each of these parentheses, since I have a coefficient of power of x and a 1 power of y only, there's really nothing I can do to make the insides of these parentheses any simpler than they are. If I had multiple x's or y's inside of any of these, I would certainly combine those together using some of the rules that were demonstrated on the previous example. So, so the next thing I would go to in my order of operations are exponents. So I would be raising each of these quantities to their appropriate powers. So what you're seeing here in this next step is I raise the 2 to the 3rd power. I'm raising the x squared to the 3rd power. Now when I raise a power to a power, I multiply the exponent. That's why you're seeing x to the 2 times 3 power, y to the 3 times 3. And I do a very similar thing with the 5xy squared being squared. I'm going to square the 5, I'm going to square the x, and I'm going to square the y squared. And so doing that would give me the multiplication of 8x to the 6th, y to the 9th, times 25x squared, y to the 4th. Now, again, I'm going to show the regrouping. You don't necessarily have to rewrite this in every step yourself. But, I am going to multiply the 2 coefficients together. I'm going to multiply the 2 powers of x together. I'm going to multiply the 2 powers of y together. So the 8 times 25 is going to give me 200. X to the 6 times x squared is going to cause me to add the exponent. So make sure you know your exponent rules, because when I multiply 2 powers of the same base together, I add the exponent. When I raise a power to a power, I multiply the exponents. And the y is going to be raised to the 9 plus 4 power. So when I simplify this completely, I have 200 x to the 8th, y to the 13th. This also carries into division. So this next one is going to show you a little bit of division. So for this, again, I could do some regrouping. I still do coefficients, powers of x, powers of y. So I'm going to do the 52 divided by 13. I'm going to do the x to the 6th divided by x, which is x to the 1st. And I'm going to do the y cubed divided by y to the 5th. And so when I do 52 divided by 13, I get 4. When I divide 2 powers of the same base, I subtract the exponents. So you're going to see here that, I see the 6 minus 1 power here, and I see the 3 minus 5 power here. So essentially, when I get my answer here to this point, 4x to the 5th times y to the negative 2nd. In some instances, this would be considered a correct answer, and you could leave it at that. Many times, though, when you see things quote-unquote simplified, negative exponents are usually not part of the mix. So a negative exponent means simply take a reciprocal. So if I see some variable raised to a negative power, the way I get rid of the negative on the exponent is simply, if it's in the numerator, I move it to the denominator. If I have it in the denominator, I'd move it to the numerator. Since I don't see a fraction bar here, everything currently is in the numerator. So in order to get rid of the negative sign on the y to the -2, I move it to the denominator, and there you have it. So let's do a slightly more complicated example where I have some multiplications, divisions, and powers being raised. For this one, there's a number of things going on here. And I'm going to first envision that the first quantity, the first division, is basically inside its own set of parentheses. And what I want to do basically is, kind of follow the order of operations and simplify by following it. So I'm going to try to do what's inside the parentheses first, which means I'm going to try to carry through the divisions that I see in this. And so when I handle those things, the first quantity, I have a 6 divided by 2 times an x squared divided by x to the 8th times the y to the first divided by y squared. And inside the second set of parentheses, I can envision that as being 4 divided by 3 times x to the third divided by x to the first times y to the fourth divided by y to the first. And of course, that's all eventually going to be squared. When I simplify the first quantity, I end up with 3 times x to the -6 times y to the -1. Inside the second quantity, 4 divided by 3 I'm going to leave as is. X to the third divided by x to the first is x squared, and y to the fourth divided by y to the first is y to the third. So I've simplified inside these parentheses as far as they can go. I really don't need the parentheses on the first group still. But on the second group I do because I need to carry through the squaring. So I'm going to square all 3 of those parts of that term that I have inside the second set of parentheses. So when I square the 4 over 3, I get 16 over 9. When I square x squared, I get x to the fourth. And when I square y to the third, I get y to the sixth. So now the exponent's been taken care of. Now I'm going to work on the multiplications. Now there's nothing but multiplication going on here, so I'm just going to draw this as being regrouped as doing the 3 times 16 over 9 times the x to the -6 times x to the fourth times y to the -1 times y to the fifth. 3 times 16 over 9 would simplify to be 16 over 3. X to the -6 times x to the fourth, I would add those exponents and get x to the -2. And y to the -1 times y to the fifth would give me a y to the fourth. Typically, when an expression like this is simplified, it's usually considered to be simplified only when you get positive exponents on all the variables. So that x to the -2 in particular, I want to think of that as a 1 over x squared. The y to the fourth, I'm going to be thinking as y to the fourth over 1. And then when I multiply this through, I get 16y to the fourth over 3x squared, which would be, under most circumstances, what is considered to be the most simplified form. So in this one here, you're given the following polynomial expression: 8 minus 11x plus 18x squared minus 7x cubed. So answer these 4 questions here, and we'll get back to it. So here you're asked, 4 questions about this. How many terms are in the polynomial? Terms are these groupings of coefficients, variables, and exponents. So you don't have to have all 3 of them for it to be a term, but if I see multiplications and powers going on, that's all considered to be in one term, whereas the plus signs and minus signs separate the terms. So when I want to count the number of terms in this polynomial expression up there, I'm going to, first of all, I'm going to realize this is x to the first power here, and I do have 1, 2, 3, 4 terms, so there's 4 terms in this polynomial. The degree of the polynomial, each term has their degrees, and the degree of the polynomial is essentially the highest power of the variable that I see in all the terms. And so the reason why I have that x to the first up there is kind of realize, okay, what is the highest power of x I see? And the highest power of x is the x cubed. So the largest exponent is 3, so the degree of this polynomial is in fact 3. What is the leading coefficient? Leading coefficient is very, very tricky because of the fact that, a lot of people think it's the first one. It's always the first, it's the one that's in the lead. Well, that's true if you had it written in standard form. And it kind of gets into the second question, or the last question that's asked here, because this is not written in standard form. We'll talk about that momentarily. If it's written in standard form, then yes, the leading coefficient would be the first coefficient you would see. But a more specific definition is that the leading coefficient is the coefficient that is the one that's being multiplied to the highest power of your variable, in this case our x. So our leading coefficient here is actually -7. And that's because this thing is not written in standard form. If it was written in standard form, it would be -7x to the third plus 18x squared minus 11x plus 8. So, and that's why now it looks more like it's a leading coefficient because it's in the lead here. It's just not written that way. So, so keep in mind that the leading coefficient is only going to be the very first coefficient if it's written in standard form. So let's answer some questions on the next page regarding polynomial expressions as well. So this one's asking you to write it in standard form. So again, I have to be aware of my powers of x. I see, I see an x to the first power here, an x squared, a constant, which would be like an x to the 0 power, and an x to the fourth. So the x to the fourth should be written first, and it always goes in descending powers of x. So it would go the x to the fourth term to the x squared term to the x to the constant. So when I write this in standard form, it's going to be 5x to the fourth plus 3x squared plus 14x minus 12. What is the degree of the polynomial? Well, the polynomial is degree is the highest power of, in this case, again, x that I see here. Now, because I don't have it written in standard form, the largest exponent should be the one written in the first term. So that's why this would be considered to be a degree 4 polynomial. Now let's do some operations with these things, and we're going to start with some addition. So here you're asked to add these two polynomial expressions together. Now for an addition, these parentheses really are not needed. So I'm just going to kind of write the first set where they're not shown there. And that standard form is also something we keep in mind because we always want to start writing it in standard form immediately. So, there's different ways to approach this. One way is to kind of just go through this and, add things together based off of where I am in my polynomial expression. So what I mean by that is I'm going to start with my highest power of x. What I can see here is the highest power of x is the -4x to the third power. I don't have any x to the third power terms beside that one, so there's nothing to do with this. So I just rewrite it -4x cubed. Now I moved on to the x squareds. I do see I have a 3x squared and a -7x squared. This minus sign right here is attached to this 7. This one's positive because there's nothing in front of it. So, and I can only add terms together. So I can't take an x cubed and subtract an x squared from it. It's impossible. I can only multiply and divide two different variables to different powers. But adding and subtracting, no. I can only, add and subtract like terms. So the 3x squared and the -7x squared are like terms. So if I carry that through, I end up with a -4x squared. Now I move down to the x's. I have an 8x and a 10x, so I can combine those two terms together, and a positive 8x plus 10x would be 18x. And lastly, I have my constant terms, so I have my -7 and my +9. If I take a -7 plus 9, I get a +2. And there is your final solution written in standard form. So this is simplified. Notice it went from having, in my original problem, I had 7 terms, and now I'm down to 4. So the simplifying is going to reduce the number of terms in most cases, or at least if I have multiple instances of the same thing, it's going to combine them together in some way. So try this next one. So I'm going to show a different way of approaching it on this one, but it's the same general principle. First of all, I really don't need these parentheses. And then the next thing I'm going to do here is I'm going to show this by me grouping things together, in the right powers of x. So I look at the 9x to the 4th. There isn't any other one, so that stays by itself. I have a negative 4x cubed and a 11x cubed being added, so I group those together. Remember that these signs are all attached to whatever immediately comes on its right. So this negative sign here is attached to the 8x. This positive sign is attached to the 6x squared. This one's attached to the 4x cubed. So forth and so on down the line. So make sure you keep that in mind. And I group them together. So the plus 6x squared and the minus 9x squared, the minus 8x and the plus 4x, the plus 7 and the minus 12. So I group them together so I can carry through these operations, based on their grouping. So 9x to the 4th is by itself, so really all I'm going to do is just rewrite that. A negative 4x squared plus 11x cubed becomes a positive 7x cubed, so I put a plus 7x cubed. A positive 6x squared minus 9x squared is going to give me a negative 3x squared, so I'm subtract 3x squared. A negative 8x plus 4x, I add those together, I would get a negative 4x, which becomes a minus 4x, and a positive 7 minus 12 would give me a negative 5, so I round this out by giving a minus 5. So the final solution is 9x to the 4th plus 7x cubed minus 3x squared minus 4x minus 5, and that's written in standard form. Try this next one. So again, I'm just going to get rid of the parentheses because it's addition. If it was a subtraction problem or other multiplications were going on, that would be fine. Standard form is kind of subjective to this because standard form, when you have multiple variables, when you determine the degree of each one of these terms, this is obviously a degree 3. So is this, because I have an exponent of 2 here, and an exponent of 1 on the y, so that combines to be 3. So this, and there might be some other ones here. They all have degree 3. This 12xy, this minus 9y squared, this plus 10xy squared is degree 3. So when I put this in standard form, it gets a little bit, there's a little bit more freedom about how you can group them together. There's certain ways that some textbooks will group them in other textbooks. But generally, as long as you have all the degree 3s coming first, all the degree 2s coming next, all the degree 1s coming, and then all the constants together, which will all combine, that would be sufficient. So as I look for this, but generally at this point, I'm just going to start from the left and say, okay, I have an x cubed. I don't really have anything that has a higher degree. I have other things that have the same degree, but there's no more x cubes in there, so I'm just going to rewrite that one. The next one over is a minus 4x squared y. There's no more x squared y's, so I rewrite that again. I have a minus 7y cubed. There are no more y cubes, so I just rewrite that one too. Plus 12xy. If I look carefully at this, I don't have any more xy, so I just rewrite that one too. Now when I get to the minus 9y squared, I do have a minus 9y squared and a minus 7y squared, so I get minus 16y squared. Next I get the plus 6x and the plus 9x. They're like terms, so they would combine to be a 15x. The minus 8 and the plus 12 would give me a plus 4. The remaining things, the 10xy squared, the minus 8x squared, the minus 11y, they don't have any more, like terms with them, so I just rewrite those. But now when I look at these and I want to put it in more of a standard form, I have to look at their degrees. So as I said, these are the degrees of each one of the terms. So when I rewrite this, I want to at least have all the 3 degrees together. I want to have all the 2 degrees together, and I want to have all the 1 degrees and the constant term last. That's generally the principle behind it. A very common way is like if you see like an x to the cubed, and I write the next degree 3, it should be an x squared with a y to the first, and I should have the x, y squared, and then the 7y cubed. So that's why you're asking me to put it in that particular order. Same thing with the degree 2s. It starts with the x squared being alone, then the xy, because there was one of each, and then the minus y squared. So I have those in that order. The x, then the y, then the 4. So it's just a lot of rewriting. But there might be some other textbooks that would have different variations of this that would also be considered correct. So, but generally you want to try to keep all your degree 3s together, all your degree 2s together, all your degree 1s together. And, but, depending on the circumstance, they may not even ask a standard form. So as long as you combined all your like terms, you're good. On to the next example. So really the only tricky part in this one, I mean, it's not much different than the previous one, except now in the second quantity, and this could be oftentimes shown in different places within one of these, you have yx squared, you have the y's coming first, and these ones that have both the x and the y. The thing about it is you have to kind of remember that, it doesn't matter which order they come in because ultimately it is multiplication. It matters what the powers are. Now, y is to the first power, x is to the second power. This is degree 3, and that's the same thing as an x squared y. So, don't get confused about the different orders because oftentimes at some point you're going to decide which one you're going to choose. And oftentimes it's usually done in alphabetical order, but every once in a while you might see one presented like this just to kind of throw you off, and don't let it. So when I rewrite this again, the first one I'm not really doing anything except really just getting rid of the parentheses. There's really nothing to change here. And in the second one, theoretically, there's really nothing to change because there's an addition here. I could just drop the quantities, but you're going to see I'm going to rewrite these. This is going to be x squared y, this is going to be xy squared, this is going to be xy. Of course, that's just y by itself and a constant. So, don't let the order in which they come in a multiplication throw you off, only because of the fact that, it doesn't matter. Y x squared and x squared y would be considered like terms, now x y squared and x squared y are not like terms because the powers are associated with different variables. So as I go through this, I start with the highest power of x's first, or the highest degrees, and it looks like the highest degree is 3. And again, we typically go in an alphabetical order, so I look at all the degree 3s first, or I try to find all the degree 3s first and then put them in order from being the highest power of x down to the highest power of y where there's no x. So I have my 12x, that should be a cube there. Sometimes I have issues transferring things over correctly, so let me correct that. So that should be a 3, not a 2. I'll just cross it out and say that should be a 3. And then when I subtract, when I have the minus 9x squared y and the plus 8x squared y, that becomes the negative 1x squared y. Of course, we write the negative sign. We don't usually put a coefficient of 1 in. Next, I move to the xy squares. I have 8 plus 5 of those, which is 13. Then I have my y cubed term, which I only have 1 of, and then I go down to my x squared term, which I only have 1 of those. Next, I would go to the xy term, and I do have 2 of those. I have the 2 and the minus 16, and 2 minus 16 is a minus 14, it's xy. Then I would go to the y squared, of which I only have 1. I also only have 1 x term, so you're going to see me just bring those 2 down immediately. I get to the y term, I do have a 3y and an 8y, so I would bring those together and get 11y, and then I have 15 and a minus 3, which becomes a plus 12. So the final answer would be 12x, and I'm just going to use, go over this in green again because everything else went over in green. 12x cubed minus x squared y plus 13xy squared plus 14y cubed minus 8x squared minus 14xy minus 7y squared minus 11x plus 11y plus 12. Most of the ones you're going to deal with aren't going to have this many terms in them, but these are good exercises to get you ready for the ones that you will tend to see more often on Keystone exams and even the practice quiz you will do following this. So be aware that you won't have anything quite as complex, but realize that, even with as number of terms there are, it's really not that complicated as long as you take an organized approach to it. Now, when we go to instances where involved in subtraction, we do have to be a little bit more mindful. So try this one where a subtraction is involved. So much like the ones with addition going on with them, in the first quantity, since really nothing's on the outside of it, that negative sign technically is attached to the quantity on its right. So the first quantity, there's really nothing going on. There's nothing on the outside like a square or anything like being multiplied to it. So I really can just drop the parentheses for that first group. The second group, however, does have a minus sign attached to it. And that minus sign is acting as a negative. That has to be distributed, which means that everything I see inside those second set of parentheses is going to have a sign change whenever I remove the parentheses. So I distribute the negative and I get a minus 14x squared, a plus 11x, minus 7. And then I look to combine like terms. I have 8x cubed. Notice I'm going to do a different version. I'm just going to cross things out. So I start with the x cubed. There's only an 8x cubed. There's no other x cubes to combine it with, so I just rewrite that. I have two x squared terms. I have a minus 4x squared and a minus 14x squared. When I take negative 4 minus 14, I do get a minus 18x squared. And sometimes you have to kind of remember that we're using negative and subtraction synonymously because we are looking at what are attached to terms. So when I look to subtract the coefficients, if it's the first one I'm looking at and there's a minus sign attached to it, I think of it as negative. And then when I do the second term, I think of it more as subtraction, and when I subtract from a negative, I just make it more negative. I have a 7x plus an 11x, so that becomes an 18x. And I have a negative 9 minus a 7, which becomes a minus 16. So the final answer is 8x cubed minus 18x squared plus 18x minus 16. So let's try another subtraction. This time you're just going to have different letters. Instead of x's, you're going to have a's. So for this one here, again, the first group, again, the parenthesis just drops out. There's really nothing I could do with that. There's no terms to combine in that first quantity. If there were, I would combine them, obviously. If there was anything being multiplied to the outside, I would do that. I would distribute that. If there was any indication of a square, I would have to go through the process of distributing that through correctly. In the second grouping, I do have that subtraction sign attached to it. So that has to be distributed. And when I distribute it, I end up with minus 4a to the fifth plus 9a cubed minus 10a squared minus 12a plus 18. So now I'm going to go through and look for like terms, starting with the highest degree. The highest degree I have is a to the fifth, and I do have two terms with that. So 8a to the fifth minus 4a to the fifth is going to give me 4a to the fifth. The next term is a 7a to the fourth. I do not have another a to the fourth term. And if I look closely, I have before I get to that, let's just put that down, move that down then. And the same thing with the a to the third. I only have one term with a to the third, that plus 9a to the third, so I'm just going to bring that down as well, nothing to do. The next ones I have appearing more than once are the a squared terms. I have a negative 19a squared minus a 10a squared, which becomes a minus 29a squared. I have an 11a minus a 12a, and that would just give me minus a. Again, you can put a 1 in front of it, no harm to that, but remember, multiple choice items, you're not going to see that coefficient of 1 in front of it because that's not written in algebra. And then I have a negative 14 plus 8, which would give me a plus 4. And that would be the final answer for this. Now, let's do a subtraction where there's multiple variables involved like we had done for the addition. So for this one here, again, much like before, the first group, I can just drop the parentheses. There's really nothing distributing in there. There's no powers being raised that I have to, do any kind of distribution or things that mimic a foiling process. For the second group, I do have to distribute that negative sign. That's the one key thing you have to remember when you do the subtractions is distribute that negative sign. So I distribute that negative sign. I'll have the plus 3 being followed by a minus 9x squared y minus y cubed plus 6x squared minus 15y squared plus 7x plus 5y minus 19. And you notice I'm doing these in a lot of different steps. And the reason why I'm showing as many steps as I am is because one of the common errors that students make is that they try to do too much in their head, and in order to save themselves some writing, which it's sort of understandable that that's attempted, but in the long run though, sometimes doing that you lose track of things. You might put the negative on the 9x squared y, but you'll leave everything else, the symbols that are inside the parenthesis, and that's not right. So be sure that whatever you're doing, that you are distributing that negative sign to all of the terms inside that second quantity. In this case, that would be all 7 of them. So now as I go through and simplify this further by combining any like terms, I'm going to start with the x cubes. I only have one x cubed term as well as an x squared y term, so I just bring those two down. Next, I would normally do the xy squared, and I have a 17xy squared and a minus 9xy squared, so when I carry through that, I'm going to have 8xy squared. Next, I would usually do the y cubed term, and I only have one term with a y cubed, so minus y cubed would be next. So these are all my degree 3s. Now I go down to my degree 2s. I'll start with a 4x squared. I have a 4x squared and a 6x squared, so I would combine those together to get 10x squared. I would next go to the xy's. I only have one term with an xy. That's the minus 9xy. And I would also proceed after that to do the y squared term, which I only have one term of that too, the minus 15y squared. So you're going to see me bringing both down immediately because they don't combine with anything. And that takes care of all my degree 3s. Now I'm going to go down, or my degree 2s, sorry. Now I'm going to go down to my degree 1. So 8x combines with the 7x, I would get 15x. The minus 4y plus 5y would become a 1y, or positive 1y, which I just write as plus y. And then I have the constant terms, 3 minus 19, which would give me a negative 16 or a minus 16. So that kind of works through the addition and subtraction. Now let's deal with the multiplication of polynomials. So in the first one here, you're going to see multiplication of binomials. When I have two binomials being squared or being multiplied, we kind of do the distributive property, and it's shown in different ways. One way that's oftentimes shown is that I'm going to distribute the 4x to the 8x and the 3, and then I'm going to distribute the minus 7 to the 8x and the 3. And so I would work out each one of these, so I would do the multiplications. 4x times 8x is 32x squared, 4x times 3 is 12x. A negative 7 times 8x is a minus 56x, and a negative 7 times 3 is a minus 21. I now look to combine any like terms, which I do have two like terms, and oftentimes when you do a lot of this process, you are going to have some like terms towards the middle. So 12x minus 56x would give me a minus 44x. So the final answer is 32x squared minus 44x minus 21. But also remember, we have a specific name for this process, this distributive property, where, basically when I did this, I was doing the firsts. Here I was doing the outside terms, here I was doing the inside terms, and here I was doing the last terms. It was also known as FOIL. So oftentimes when you're multiplying two binomials together, you do a process that's known as FOIL. I mean, the process is very similar when you have situations where you have more than binomials being multiplied to each other. It's not technically called FOIL in that instance anymore because you have more than just 4 multiplications to do, but that's what this is indicating. There's 4 multiplications to do. A lot of times the O and the I part of the foiling process ends up being where you have your terms that can be combined together and any like terms that could be merged. So keep on the lookout for those. That's not the only place that they can happen, but most often that's where they happen. So try the process again on these two binomials. Okay, so for this one here, I'm going to use more of the FOIL process. I'm going to do first, which would be the 8x squared times 6x, the outsides, which would be the 8x squared times the negative 5, the inside terms, which would be the negative 9 times the 6x, and then the last terms, which is the negative 9 times the negative 5. So when I carry through each one of the multiplications, following my order of operations, 8x squared times 6x is going to give me 48x cubed. 8x squared times a negative 5 would give me a minus 40x squared. The negative 9 times the 6x would give me a minus 54x, and a negative 9 times a negative 5 would give me a plus 45. And that's what I get when I do my multiplications, and when I look at this, I have no like terms. So at this point, I'm done. So everything has been simplified as far as it will go. This process, again, although we wouldn't call it FOIL anymore, as I mentioned before, can be used when I have, bigger quantities being multiplied together. So here's a binomial being multiplied to a three-term polynomial, also sometimes known as a trinomial. Okay, so much like we did before, I could kind of view this as me taking this first quantity and distributing each term to the three terms of the second quantity. So in this instance, I'm going to take the 8x times the 3x squared plus 5x minus 11, and the negative 7, or minus 7 times the 3x squared plus 5x minus 11. In each case, I distribute a second time, so the 8x gets distributed, with giving me 24x cubed plus 40x squared minus 88x. And then when I distribute the negative 7, I get a minus 21x squared, a minus 35x, and a plus 77. So everything's been multiplied through now. Now I look for any like terms. And I can see the like terms here. I have the 40x squared and the minus 21x squared. I have the minus 88x and the minus 35x. So those will get combined. The 24x cubed and the plus 77 get left alone. So you'll see those in the answer. Of course, 40x squared minus 21x squared is going to give me a positive 19x squared, so I have a plus 19x squared down there. And a negative 88x minus a 35x is going to give me a negative 123x, so you see the minus 123x. So let's try one last instance. This one's going to have kind of a number of things. You're going to have a binomial being multiplied to a four-term polynomial. And along with that, you're going to see both x and y terms being used. So keep track of everything as you go through this one. Okay, so again, as we do this one, I'm going to kind of view this as me taking this 2x and plus 5y and distributing it to this quantity here. So I'm going to write it as that. 2x times the 3x squared minus 4xy plus 7y squared minus x plus 7, and the plus 5y being multiplied to that same quantity. In each case, now I'm going to distribute. So I'm going to distribute the 2x to the first quantity, to that second quantity, and I'm going to then distribute the 5y, and this is what you see when we do that. So I get 6x cubed minus 8x squared y plus 14xy squared minus 2x squared plus 14x. That's all from the first multiplication. And I have plus 15x squared y minus 20xy squared plus 35y cubed minus 5xy plus 35y, coming from the second multiplication. Now I like to put this in some sort of standard form. So I'm looking for the highest power, the highest degrees of each term, so I can put them in the right order. So when I look at these, the 6x cubed has degree 3, the 8x squared y has a degree 3, the 14xy squared degree 3, and all the other degrees are given. And I also underlined some like terms. So I only have two sets of like terms that I'm going to have to combine. Everything else is just going to get rewritten. I just have to make sure I write them in the right places. I at least want them grouped by degree 3s, degree 2s, degree 1s, and any constants, which I don't have in this instance, together. So degree 3s, you're going to see that I'm going to have the 6x cubed, the minus 8x squared y, and the plus 15x squared y is going to give me a positive 7x squared y. The 14xy squared minus the 20xy squared is going to give me a minus 6xy squared. I then have the 35y cubed, Then the minus 2x squared, the minus 5xy. There's no y squared term, so I move on from that. I move on to the 14x. There is no, there's a plus 35y term, and then there's no constant term. So that's my final answer down here with all the terms that you see. And that is the last problem from this practice. If you have any further questions, please make sure to reach out to me and let me know. But go through this, go through any of the additional videos that you had from the review to kind of get the idea again, if you need to review any of them a little bit more thoroughly, and then try the quiz. Until next time, have a good day.